All right, let's talk about osmosis. So, a couple of terms to refresh yourself with. Semi-permeable membrane is one that allows some compounds to pass through, but not all. Solvent is usually going to refer to water. It's whatever you are dissolving something into, while a solute, frequently a salt, is what it is being dissolved in, or what is being dissolved in. For instance, if you look at your Dr. Pepper, the first ingredient is water. Water is the solvent. If you are making sweet tea, water is your solvent, sugar is your solute. Technically, tea is also your solute, but it's for a different discussion. So, as I mentioned when we talked about passive transport, osmosis is the net movement of water across that membrane, trying to equalize the solute concentrations on either side. It is going to move from a low solute concentration to a high solute concentration. Here's an example of that. This is salt water. There's a semi-permeable membrane right here, preventing the salt from moving across. And here we have the water coming over, trying to even it out. Which means, as we mentioned, we have something generated called osmotic pressure. Osmotic pressure, remember, is the amount of water that is needed in order to, or amount of pressure, I should say, needed to stop osmosis from occurring. We're also going to have things like osmotic imbalances. Osmotic imbalances can cause cells to dry out from losing too much water, or swell and break from too much water coming in. Remember, water chases solute concentration, so that's going to be driven by the solute concentration on each side of the cell. We have terms for this. If a solute is considered, if a concentration is considered hypertonic, a cell will lose water. Now, this brings up a point. We need to talk about something. Whether or not a solution is hypertonic, hypotonic, or isotonic is dependent upon the fluid outside of the cell. The reference point is the cell. We're talking about what is outside the cell. So if a solution is hypertonic, the solute concentration is greater outside the cell than inside the cell. Therefore, the cell will lose water because water is leaving the cell. The cell is going to shrivel up. Hypertonic solution. If, however, the solute concentration is greater inside than outside, the solute concentration outside of the cell is considered to be hypotonic. Water is going to flood into the cell, causing it to swell and potentially burst. If, however, the solute concentration is equal on both sides, you're going to have water moving freely back and forth. It's not going to be stagnant. It will still move through the membrane, but it will be equally back and forth, and this is referred to as an isotonic solution. Here's an example of that. Now, this is a plant, and the thing with this particular example is plant cells have a plant wall. Plant walls don't, or I should say, prevent the cell from bursting when they swell. So you can see here, it pushes against it, it bulges a little bit, but it doesn't burst, unlike the animal cell up here. So plant cells have this mechanism in place. And this is an example using blood cells. Here we continue. These are electron scanning microscope images of what these cells look like if they are hypo, iso, or hypertonic solutions outside of them. This would be an egg. You can actually do this at home. If you carefully peel an egg, raw egg, so that the shell is off, but the membrane is still around it. There are ways to do that without actually peeling their solutions. You can put it in that dissolves the calcium in the shell. leaving it the membrane around it, and then you put that membrane-bound egg into, they did corn water here, or corn syrup here, but a salt solution. I've seen that one in the past. I've seen milk in the past. You can actually see it. I mean, it shrunk, it shriveled. This was hypertonic. This was hypotonic. This was equal. Why do we care? There is this concept that I'm going to mention over and over and over and over and over and over and over again called homeostasis. Homeostasis is the body's ideal operating zone. It's its happy place. It's its toes in the sand, fancy fruity drink with an umbrella in its hand, nice, relaxed, everything sunny side up state. It's working the way it's supposed to. Nothing's malfunctioning. It's getting what it needs. Nothing more, nothing less. It is good to go. That's homeostasis. Super, super important. Because everything in your body operates within a zone. Disease only occurs when the body is outside of its ideal operating zone, for whatever we're talking about, and unable to correct itself. That is disease. So homeostasis is the foundational concept of disease. Okay, back to water. What does homeostasis and water have to do with anything? Well, if you are dehydrated, your blood becomes concentrated. This is going to create a hypertonic state. The blood cells are going to lose water, they are going to shrivel up, and they are going to die. And even if they don't die, they're not going to be able to attach oxygen like they should. That is dehydration. That's one of the many, many problems if you become dehydrated. It's also why if you're dehydrated, you feel really foggy and sleepy because your brain isn't getting the oxygen that it needs. Your oxygen is a greedy glut when it comes to oxygen and glucose. So if you're not getting the oxygen you need because you have a respiratory condition or you're dehydrated, so your red blood cells are shriveled and oxygen can't attach to them, you are going to have brain fog. You're going to be sleepy. You're going to be tired. Now, you might be going, okay, but I drink like 80 ounces of water a day. Why don't I become overhydrated? Here's the thing. Overhydration is a thing. It can occur. We tend to see it in endurance athletes, marathon runners, ultra marathon runners specifically. Your average adult, typically, we don't need to worry about it. But it is a thing. You can do that. Far more likely to occur, though, is a condition called edema. Edema is fluid buildup. Fluid buildup can occur due to a variety of different reasons, but how do I want to phrase this? The base cause is going to be the cellular fluid is less concentrated. So fluid is going to run into the cells, causing them to swell and burst and lyse. And that is just going to feed into itself. Which means in order for your blood, your intracellular fluid, your extracellular fluid to all remain roughly isotonic, you need to have a properly functioning heart, a properly functioning lymphatic system, and properly functioning kidneys, as well as getting adequate water intake. 4 things have to happen. Welcome to the human body. It's super complicated. And I don't say that sarcastically. I do mean that honestly.